Dear aspirants, welcome to my channel. This is your model question paper 1, Electronics and Communication, semester 1, Digital Electronics, subject code is 25EC11I. So today in this video, you are going to learn 2 marks questions. Okay. So describe 2 features of BCD code. So in this BCD code, in the BCD code, we can represent digital decimal digits in representing a 4 bits. Okay, you can represent. Okay, this BCD code we can use it to where you have to use. We can use it for digital displays and calculators. You can use. The next question is converting the binary number is given here. We have to convert to decimal equivalent. So here we just see the binary numbers. We can write it like this. Binary digit. You can make a tabular column like this, and position and power. So based on the position, so you can write the first position, second, last position. There is a fifth positions will be there, so that you can write it. So there is sixth, which is the first position will be 2 to the power 0, 2 to the power 2 as given here. So we have to make it 2 to the power 0, 2 to the power 1, 2 to the power 2 like this. And we have to, what is the 2 to the power of 5 will be in 32, 2 to the power 4 is 16, 2 to the power of 3 and 2 to the power of 2, 4 and hard numbers and even numbers we have considering. So if you get that become 0. So then, so whatever product will be there that you have to write it here. So you can write 1 into 2 to the power 5, 2 into 2 to the power 4, 0. Okay, that number will be there, right? Same number and this number, okay? 0, if you multiply anything you will get 0 only. And this, and finally you will get 53 will be an answer for this. You can write like this and you can solve like this the problem. And define variable and constant. So variable nothing but the name only indicate, for example, the value going to change. Variable nothing. Variable means a symbol whose value can change, that we call it as a variable. It may A, B, X. And constant means it's a fixed, the number does not change, number anything does not change, a fixed value does not change, that is we call it as a constant. 0, 1 you cannot change, that is the constant. And next, explain the importance of De Morgan's theorem. So what is the importance, why we have to use De Morgan theorem? Okay, this, if you use this De Morgan theorem, we can it is help to, you can simplify the Boolean expressions what is there, that you can simplifies, and based on the De Morgan theorem, and we can use it for whatever design circuits will be the NOR gate, NAND gate, you can easily design it. So this NOR gate and NAND gate you can easily design, that purpose we are using De Morgan theorem. Next is simplify the Boolean expression. They given expression here, by using Boolean algebraic law you have to simplify this. Here the Boolean expression we given, first given expression you have to write it. So in that you have to see the common, A will be a common. Okay, so we are using distribution, whatever law they told, no, that law we have using, this is distribution law. In the distribution law, whatever law we have used, that we have applied. A, you have to take out a common from here, that you will get 1 plus AB into ABC, this distribution law we have used. Then next step, go to the next step, we can use complement law. Complement law nothing but 1 plus B is equal to 1. So 1 plus B here is, so we have written here 1, and as it is you can write it. Next, go to the identity law. Identity law into A into 1 is equal to A. So we have used here, A into 1 is there, we have used identity law. Okay, so after using identity law here, next we have to go for the absorption law. So in this absorption law, that equation become like this, A plus A into B into C is equal to always AB. So the expression will be same as it is here. So it become Y is equal to AB. So these are the laws we can use, and we have solved this. Next, mention any 2 example of combinational logic circuits. So it is a multiplexer that we call it as the MUX, and decoder. So these are the 2 combinational logic gate circuits. So this, based on this we can find out this combination circuit, why we have to use it, should be depending, this circuit should, this combinational logic circuit should be depending upon our output depend, it will be on, based on that it will be represent the input values. And what is the role of combinational logic circuits in a microcontroller? What is the role if you use combinational logic circuits? And what is the use of combinational logic circuits in a microprocessor? So you can process the data, and you can take a decision making. Here they represent perform data processing and decision making operations. And also one more help about the function, we can find out the arithmetic calculations and data selection, coding, decoding, and control the signals generation based on the input condition. Whatever condition will be there, that you can explain, and it will be these are the help for the conditional logic circuits in the microprocessor. Next question, define integrated circuit. We call it as an IC. List any two IC circuits. Okay, integrated circuits. Okay. So integrated circuits, nothing but it is a combination of whatever circuits which will be helpful for the in the electronics. So it is a IC circuits is a electronics device. So which may components like a transistor, resistor, capacitors, and fabricated, it make a single semiconductor chip, that we call it as an integrated circuit. See, integrated means combination of all circuits. So coming to an example, it is an IC 7408 is one, and IC 55 timer is one of the type of IC circuits. So if the content is useful, please subscribe my channel, share and support. Thank you.